Hey everyone, welcome to the first day of Unit 2. Let's go ahead and set up our Falcon notes with a line going all the way down the left-hand side of our paper and a line going all the way across. We're going to label this notes Lesson 2.1, One-Step Equations. This is where we're going to start in Unit 2. Let's go ahead and write down our essential question. How can we solve basic equations? Now, before we get started, we are going to just answer or fill in a few vocabulary terms that we have here. Our first vocabulary term is equation. An equation is a statement that sets two things equal to each other. Notice that equation and equal all start with the same four letters. This just means that every time we see an equation, we should have an equal sign in there. Our next definition is solve. This means to get a variable on one side of the equal sign by itself. Now, a variable is just something for us that is unknown. In math, a lot of the times we use letters as variables, and the most common one is x. So if you have a question that says solve for your variable, solve for x, your goal is to get x alone on one side of your equal sign, because an equal sign splits up an equation into a left side and a right side. And we want our x to be all by itself on one of those two sides. Our next definition is solution. A solution is a value that we can put in place of a variable, such as x, that makes the equation true. So if we think of a true statement, an example of that could be something like January is the first month of the year. That is a true statement. Another example of a true statement could be 4 equals 4. We know that 4 definitely is 4, or 2 equals 2. An untrue statement would be something like 3 equals 2. 3 does not equal 2, so that is not a true statement. Our next term is simplify, and this means to make things less complex. It's the process of replacing a math expression by an equivalent one. One thing that I like to think about when we are simplifying something is to make something smaller. We're trying to condense it. We're trying to make it smaller so it's easier to work with. Then we have like terms, and like terms are terms whose variables are the same. Now, and just in this unit, we're only going to be working with variables, but eventually they need to have the same variables and the same exponents as well. And just a quick reminder, an exponent is like that little tiny number that you would see above and to the right of a number. So we could have 2 to the second or x to the second. These little numbers are exponents. Okay. So when we solve, we need to use operations and opposite operations. We have 4 operations: addition, subtraction, multiplication, and division. And when we solve, we use the opposite of those. So if our original equation has addition in it, we would use subtraction. If our original equation has subtraction, we would use addition. If we have multiplication, we would use division to help us solve. And if we have division, we would use multiplication to help us solve. So what I want to look at next, just before we start, is just multiple representations of multiplication, because this is where I notice that students get tripped up quite a bit. We all are very familiar with the multiplication symbol, that is the X and the little dot. Those both mean times. But we also have parentheses, and this can also mean multiplication. And we also have nothing. So if you see a number right next to a letter with nothing in between those two things, that means multiplication. So 3x really just means 3 times x. So now let's get into the nitty-gritty of it, solving actual equations. Whenever we solve equations, we first always need to get rid of anything that has parentheses, and we also need to combine like terms. Now today our goal is only to do one-step equations, but when we get into multi-step equations, this little tidbit is going to be super important. But it doesn't really affect us much today. Also, when we solve, we use PEMDAS in reverse. So just a quick review of what PEMDAS is. This is our order that we do equations in. P stands for parentheses. E stands for exponents. M stands for multiply. D stands for divide. A stands for add. And S stands for subtract. So when we solve, we go in the reverse order. We do subtraction and addition first, then division and multiplication. Parentheses and exponents, those are very rarely used in equations that we're going to solve this year. So we're just going to focus on the subtraction, addition, division, and multiplication. So now we can jump into some examples. Our first example is 26 equals x plus 8. Whenever I solve equations, the first thing that I typically do is draw a straight line right where my equal sign is, dividing my equation into a left side and a right side. So then I have to identify my variable that I'm solving for. I am solving for x. So I'm going to box that in because that's the thing that I want to get by itself. So right now my x is on the right side, and I also have a plus 8 on the right side with it. I need to get that plus 8, I need to get that plus 8 and move it to the other side. In order to move it to the other side, I need to use opposite operations. The opposite of adding 8 would be subtracting 8. Whatever I do on the right-hand side of my equation, I also need to do on the left-hand side. So I'm going to subtract 8 to the 26. All right, so then I do 26 minus 8 on my left-hand side, and I get 18. I'm going to bring down my equal sign. I haven't touched my x at all, so that just gets dropped down. And then plus 8 and minus 8, since those are opposites, they cancel out. What you should see now is that your x is all by itself on the right-hand side of the equation, and it's equaling a number. So what this means is that you've now solved for x, and you're done. All right, let's look at the next example. I have x plus 4 equals negative 12. Again, drawing my straight line right where my equal sign is to split it up into a left side and a right side of my equation. Identify your variable that you're solving for. I'm solving for x. I see that I have this plus 4 on this left-hand side with my x, so I need to get rid of plus 4. The opposite of addition is subtraction. So I am going to subtract 4 on both sides. I haven't touched my x at all, so that's going to just drop down to the next step. Plus 4 and minus 4 are opposites, so those just cancel each other out. I'm going to bring down my equal sign. Here's the tricky part. I have a negative minus something. Look at the signs. If they are the same, you add the number and keep the sign. So both of these have a little negative sign in front of them. Negative 12 and minus 4. Minus, subtract are also just another way for you to say negative. So they have the same sign. So we add the two numbers together. So 12 and 4 give me 16, and we keep the sign. So since the signs were both negative, it's going to be negative 16. What you should see now is that your x is all by itself on the left-hand side of your equation, and it's equaling a number, so you are done. All right, let's look at another example. I have 15 plus x equals 23. Drawing my straight line down where my equal sign is, splitting it up into my left-hand side and my right-hand side of my equation. I need to get x by itself, and I have this 15 right in front of it. So this 15, there's nothing telling me whether it's positive or negative, and since there's nothing telling me that it's positive or negative, we assume that it is a positive number. So in order to get rid of a positive number, we need to do the opposite of positive or addition, which would be subtraction. So I'm going to subtract this 15 from both sides. 15 minus 15, those cancel out. So those just go away. I haven't touched this x, so I just have to bring it down to the next step. The plus sign, again, is just one of those things. It's just telling me that my x is positive. We don't necessarily need to write that plus sign in the next step here. And then 23 minus 15 gives me 8. So now what I should see is that my x is by itself on the left-hand side, and it's equal a number. So I have solved, and we are done with that problem. All right, let's look at example D because these are a little bit different. It's going to start off the same with me splitting my equation up into the left side and the right side. But what you should see now is that I have a number directly attached to a variable with nothing in between. I have no plus sign in between. I have no minus sign in between. I just have a number attached to a variable. This means multiplication, right? So 10x equals 40 really just means 10 times x equals 40. So if I want to solve this, if I want to get this 10 and move it to the other side, because my goal, remember, is to get x by itself, I need to do the opposite of multiplication, which is division. Oops. So I'm going to divide both sides by 10. Dividing both sides by 10 cancels my 10s out here, leaving me with just an x, and then 40 divided by 10 is 4. What you should see now is your x is all by itself on the left-hand side. It's equal to a number, so you are done. Let's look at example E. I have negative 7x equals 21. Again, no addition or subtraction sign in between the negative 7 and the x, so this just means negative 7 times x equals 21. In order to get x by itself, I need to get rid of this negative 7. It's being multiplied, so I need to just divide by negative 7 on both sides. When I divide, my negative 7s cancel each other out, and I'm left with just that x. And then 21 divided by negative 7, if we have a positive and a negative being divided or multiplied, it results in a negative. 21 divided by 7 is 3. So we have x alone on one side of our equation, and it's equaling a number, x equals negative 3. We're done with that problem. F is a little bit different. So what we have here is x over 4 equals negative 13. This little bar that you see, that means division. So whenever we have like a fraction, we have to remember that fractions mean division. So right now, my x is being divided by 4, and that is equaling negative 13. So what we have to do in order to get rid of division is the opposite operation. The opposite of division is multiplication. So if I'm dividing by 4, to get rid of it, I need to multiply both sides by 4. So I'm going to multiply the left side by 4, and I'm going to multiply the right side by 4. When I multiply the left by 4, the 4 and the 4 cancel each other out, leaving me with just an x on the left-hand side. And then on the right-hand side, I have negative 13 times 4. 13 times 4 is 52, and then since it's a negative and a positive, we end up with negative 52. So what you should see is I have x alone by itself on the left-hand side equaling a number, so I am done with that problem. All right, we have 2 more examples to go. I again have x over 8 equals 2. Remember, this bar means division. To get rid of division, we need to multiply. So if I'm dividing by 8 here, to get rid of that, I need to multiply by 8 on both sides. My 8 and my 8 on the left side cancel out, leaving me with just an x. On the right side, 2 times 8 is 16. We are done. Last example. I have negative 16 plus x equals negative 15. My goal is to get this plus x by itself. I have a negative 16 here that I need to get rid of. The opposite of negative is positive. I'm going to add 16 on both sides. My negative 16 and my positive 16 cancel each other out. I haven't touched my plus x, so that just gets dropped down. We don't need to bring that plus sign because we automatically assume that it is positive if there's nothing in front. I bring down my equal sign, and what we have here is a negative number and a positive number. If they are opposite signs, such as this, you take the bigger number and subtract the smaller number. My bigger number here is 15. So I'm going to do, or sorry, my bigger number here is 16. So I'm going to do 16 minus 15. 16 minus 15 is 1. And then you take the sign of the bigger number. My bigger number here is 16. That sign is positive. So this is going to be a positive 1. So I have x equals 1 as my final answer. So in summary, in order to solve equations, and these are one-step equations, solve one-step equations, we must use opposite operations. All right, you guys, I will see you in our Zoom meeting. Bye.